Today, we're doing the second page of our packet. Learning targets are cool, but we're going to, our order today is pretty much, we'll go through an example together, and I'll talk through an example, and then you guys will do one on your own. So it's going to be a lot more back and forth. There's not like a 20-25 minute lecture and then just work time. Like we are working kind of on this together and going back and forth. So if we look at the first question on that packet, right, we have something similar to actually what we saw yesterday, right? Right? Similar to what we saw yesterday, kind of? Yeah. Yep. Where we are dividing two fractions. When we have the big division bar with two fractions, what do we need to do to try to solve this? How do we solve this? Come on, people, this is sixth grade. Yes, thank you. Yes, yep. Maybe what you have heard is we change from division to multiplication, and we flip. So we keep 8 over x squared, we change from division to multiplication, and we flip to multiply by x over 4. And this is the division example in your packet. So the first one, you want to write this with, we multiply across, we get 8x over 4x squared. This can be simplified to 2 on top and just x on the bottom. Now, that's not a very good color, sorry, but in the packet, in day one yesterday, it talked about a lot of times how you had to write what x could not equal. And what, for every single problem, what could x not equal yesterday? Yeah, 0. All of them, x could not be equal to 0. Because our denominator had an x in it, and if x equals 0, then it would be undefined, right? We can't do 8 divided by 0, it's undefined. For these ones today, we still are going to have some where x cannot equal 0, but there also are going to be different things that x cannot equal. In this case, what can x cannot be equal to what? Just to keep this to stay out of the undefined. So we look at these denominators. Yeah, x can't equal 0. There's nothing else. So this follows the pattern of what we saw yesterday, but the ones that we're looking at more today, the rest of these examples, we'll use some different strategies that you didn't see yesterday, and x, we'll have to look a little bit closer at our starting equation to see what x cannot equal, okay? Today, pretty much all that we're going to do, and you can see the examples on the left-hand side, is it gives you some type of equation or expression to try to simplify it, and we need to try to come up with and use different strategies to simplify these equations. So this is more like what we will see today. Why does it say multiplication but have subtraction? Yours is what?
Ours has multiplication.
Yours has multiplication. Where's my multiplication? Let's go on.
Yeah, that one right there is the same number and then the subtraction.
Isn't it 4x squared minus 1?
Oh, yeah.
We'll make a audible. Times. There we go. Now this is more like what we'll see today. This was just kind of you could say a warm-up problem, but that is a lot more like what we saw yesterday. Today the problems will look a lot more like this, where they have some type of trinomial or binomial, some type of polynomial that we have to look to factor first, and then we will try to simplify. So if we're looking at this example right here, we want to first try to cross some things out and try to simplify. Because if we were just to multiply these two fractions, we would have to FOIL this binomial over here and this trinomial on the left-hand side. And that would be like massive to FOIL, wouldn't it? So first we want to try to factor this, or write both of these fractions in kind of a different form, so that we can cross some things out and then multiply. So if we were to factor, let's start with this trinomial right here, this whole thing. If we were to write it in factored form, what would that be? Yeah, Ryan?
X minus 1 and x minus 3.
Yep. Good. What about the numerator, or the denominator there? Can we factor that at all? Write that in a factored form? Say that a little louder. Whoever said that. I don't know which one of you. I know it was one of you two.
I said it's in order to like get rid of the middle one that has the plus and the minus.
Yep.
I don't know. Oh wait.
Can we rewrite this at all? What about the bottom? What can we do with x squared minus 3x? What can we factor out of that? Next. Now, let's backtrack for a second. Okay, let's think way back to, well, I don't even know what grade it would be. Middle school. If you had something like this. What did they tell you in 6th or 7th grade to do before you multiply across?
Simplify.
Yeah, they told you to simplify. What could we simplify here? Yeah, perfect. What about if you had, what if instead of a 6, this was a 12? What would you be able to do with it?
1.
Yeah, you would just be able to cross these right out. It would become 1, it would become 1. Now we want to take that same idea and apply it to our binomials, to our factored, all our factored expressions. So if we look at the cross, not the cross products, but these opposite sides, can we cross anything out? Yeah. What about the other direction? Yeah, 2x plus 1. Now that helps us multiply a lot easier, right? That's a lot simpler to multiply. On top, we're just left with x minus 1. On bottom, we have x times 2x minus 1. Now, to write this in simplest form, we would want to distribute this x on the bottom. Like that. But that would be writing it in simplest form. Now, one thing that can help, you probably look at some of these, like how we factored this out. You're thinking, well, geez, I didn't even know where to start to try to factor these. One kind of hint, when we're looking to factor this trinomial, this trinomial up here, we probably want to look at this opposite to see if there's anything we can do to have them have those same factored binomials that we can cancel out. When we look to factor this right here, we probably wanted to look opposite to see if we can write one of the binomials in that form so we can cancel things out. It kind of gives you a hint, gives you a clue or a direction to go. Do you guys see what I'm getting at? Looking at the diagonals before you start to factor. Now, our last step. We need to write what x could not equal. Right? There are a few things that if x was a couple numbers, then we would get undefined when we look at this equation. So, what do you guys think? What could x not equal?
0.
Yes, x could not equal 0, because right here, if x equals 0, that denominator would 0 out and we'd be undefined. What else could x not equal? What? What else? There are 3 more numbers. Positive 1 would be something. Oh, wait. JK.
JK. Just kidding. Psych.
We could put 1 in. If we look at our factored, if we look here at the bottom, if we put 1 in, none of these would go to 0. So we would be okay. What if we look right here? What would make this 0? 3. X could not equal 3. What about right here? What would make this 0? We got swoop. Don't you guys remember swooping?
No.
Swoop. There it is.
No, we didn't do that.
Oh my goodness. Are you serious?
Yeah.
It should show no cap.
Okay. That means you're not lying, right?
Yeah.
If we have 2x minus 1, we're trying to see what makes this 0. We just need a swoop. We need to take our number with x and swoop. There it is. That would be 1/2.
Oh,
Whoa, yeah.
Swoop.
We're
There
gonna
it
have to
is.
go over that again.
she's trying to teach us that, like, I was confused.
No,
So
she-
we-
She just kept saying swoop.
Yeah,
If
she
we
kept on
swoop,
saying
and if we swoop, we'd have, it could not equal plus or minus 1/2.
She said we didn't have to.
Now,
Like, now we
the reason that, last thing with this question, and then you'll do one on your own. When we write it in factored form like this, it helps us simplify and cross things out, but it also helps us see what our zeros are, right? If you look right up here at this original denominator on both sides, there's, I'm not going to say there's no way, but that's pretty tough to see what your zeros are just looking at that first one. When we factor everything out, we have done the, well, we should have been doing swooping since like algebra, and we've been looking at zeros at least since algebra 1. So that would be how we simplify something insane like that starting equation. We'll multiply that together. Did I get that one right?
Yes.
Yep. So this is how this packet is going to go a little bit more. I'm going to show one. We'll talk through one slowly like that. Then you're going to have a couple minutes, and you need to do problem number 3. I'll give you just a couple minutes to work on that. And then pretty much I'll show another example of a different type of problem, and you'll do one on your own. There'll be a lot more back and forth. So virtual students, this would be where you probably want to fast forward like 5 minutes to where I show the next example. Yeah. It might be nice to have some of those. That's the tough one to factor, right, in your head. Some of them are tough to factor in your head. I get a calculator and I graph a lot of those because you probably don't want to do the quadratic formula for that whole thing. But maybe graphing would be helpful, or maybe the quickest. Or did you know that you're probably not every time, but most of the time you're going to try to cancel something out. So you know that that is one of your factors, right? Then you can figure out the other one pretty easy, like check it. Make sure. You know what I mean? This top one's pretty tough to factor. So I would recommend looking at this diagonal to see if you can split this up with 2x plus 1 times something else, because you would like to be able to cancel. Right? That's the whole reason we're trying to factor this, so that we can cancel a few things out. So the only way we could cancel out this denominator is if we have 2x plus 1 up here. So if that's one of our binomials that we're factoring, then that would be huge. That would be helpful. That's up for you to look at. We got to practice our factoring. Graph it and see. Right.
last one, last problem, we didn't do anything with it.
Well, this is 2x plus 1, and this has to just be x. And if we need a minus 3, then this has to be minus 3, doesn't it?
Oh, I was looking at
Now we can check. 2x times x gives me 2x squared. Times a negative 3 is negative 6. Plus 1 is negative 5. Minus 3, so this works. So we factored it. Can we factor this?
Yeah, I already did that one.
What'd you get?
X minus 3 and x plus 3.
I was listening because you said something about Upward. Are you trying to work there? Where at? Golf shack?
No.
No? Where then? The restaurant? Oh, nice.
You see Max.
Yeah, I see him.
Yeah, I talked to Max about you the other day.
Oh yeah.
We can cancel these. Now look, what we didn't have in the last problem. This x minus 3, if we're looking at the one we're on now, we should have factored the top, factored the bottom.
Wait a minute.
We can cross out the diagonals, but what else can we cross out in this fraction? Anything?
X minus 3.
Yeah, the x minus 3s can go.
So it's just 2 over x plus 3.
Yep.
You can cancel out when they're above each other.
Well, yeah, think about it. If you have,
I thought it was like cross over here.
yeah, but you're simplifying the fraction. If you have 12 over 16 times 1/3, you could simplify this, right? That's, I mean, 12 is 3 times 4, 16 is 4 times 4. You can cross those out. We do all this stuff all the time with regular fractions, but when we get to polynomials, we kind of forget all the rules.
Would that be 2 over x plus
Look, you're teaching from very good teaching.
Good job. And then make sure you write what x could not equal. You can see right here, there'd be 3 numbers that x cannot equal. X cannot equal. About 10 more seconds. And if you don't finish this one, you can circle back to it.
Can you tell them how many there are?
Well, you can just look at the, that's maybe like which one of these.
Or you can stick out 0 on it.
No, there's no question about it. I know I at least got 1 or 2.
Out of what, 20?
32. I know I at least got 1 right.
2 out of 32.
But it should not be easy.
It's great.
I was 6 out of 24.
You showed me first.
Yeah.
What's that?
Yeah.
I'm confused. It says addition with method and that's subtraction.
Why are you all
We're literally just on
I know. No, my mom.
No, it says addition. Additional.
Oh, yeah, that is what it says. I'm not,
I'm just saying it's addition.
right. I mean, it applies, it really should say addition or subtraction, because it would, we have to get a common denominator. That's the
I was
key.
just gonna say because all of you say addition.
Yeah, this is classic, like, this is chick business stuff where they have, like, 3 papers that they want to combine. So they, like, lay them over each other, and just scan a copy of it, and it just kind of, I'm not roasting them, I'm saying, like, just,
If I would have
there's probably a couple little updates that would help.
So why do we like know x could not equal that? Like I just left the hers for 3 and 3.
Yep. So if we look at the bottom of our denominators here, if any of this equals 0, this will 0 out. We have some number divided by 0 is divided by 5. So if you think about this as this is something that we were trying to graph, these, if x equals 3, that point would not show up on the graph because it would be on the line. If there's no y value.
Johnny's seeking an
So
out.
whatever numbers make our denominator 0.
So next thing
Let me see what I get real fast.
All right, let's look at the next example. So the title says addition with a messy denominator, but addition or subtraction. Okay? Our example is addition or subtraction. So we have 3 minus 1 over x plus 1. Anytime we add or subtract fractions, what do we need to get? Common denominators. Good. So this is really 3 over 1, right? So what do we need to multiply that 3 over 1 by to get a common denominator? X plus 1. Yeah. So when we get our common denominator, we have 3 x plus 1 over x plus 1, because 1 times x plus 1 is x plus 1, minus 1 over x plus 1. So now that we have a common denominator, we can just subtract straight across. So let's distribute that 3 and subtract. So we have 3x plus 3 minus 1 over x plus 1. Now if we simplify, is there anything we can do to further simplify or factor or anything like that? Yes.
Should we do it like 3x and x equals 2x?
Make what to it?
Where it's like 3x and x equals 2x?
We can't. Since it's addition, then we can't. If it was all multiplication, then we could. That's in simplest form. So now we just need to write what can x not equal. If we look, we can look at our original for this one since it's not anything insane. Or we can look here. X could not equal -1. Right? If x equaled -1, the denominator would zero out and it would be undefined on our graph. Oh, we did it again. Just so you guys know, quick pause. Probably big hand on the nine. We're gonna try to start using it. Why don't you guys go ahead and do number 1? So right at the top, on the right hand side, number 1. Messy denominator. Did I get you the packet, please? Oh, sorry. I thought I put one on every seat. You guys should be working on number 1. We have 2 more examples that we're going to look at. So, we're going to spend a couple minutes, about 5 minutes on each of them. And get through what we need to today.
You did? Oh.
That's okay. I'm not worried about that.
Yeah.
Tessie? Actually,
Okay.
I can't.
That was a lot easier.
All right, so let's look at 2 messy denominators. What do we have to do before we can subtract? Yeah, we have to get common denominators. In this case, well, let's think back to what would you do if you had this right? Yeah, you know the common denominator is 15, but really you're multiplying, so you would multiply this by 5 over 5. So you multiply by this denominator, you multiply this by 3 over 3. Right? right, to get 15? Okay, good. Now we're doing the same thing, except with polynomials. We need to multiply this side by x minus 1 over x minus 1, and this side by x plus 3 over x plus 3. So we need to multiply each side by our denominator. That would give us 4x minus 1 over, and we're just going to leave these in this 4x. Factors 1. So now we have common denominators, right? Yeah, so we can subtract. Let's simplify and subtract. Well, maybe not both at the same time. We distribute this 4x minus 4 minus, we have x, and that negative would have to be distributed in the middle, so we have minus 3. You guys follow up, please? We distribute the 1, and we have to distribute this negative over the top of x minus 1, x plus 3. Now let's see. We have a positive 4x and a negative x, so that would be x 3x. We have a negative 4 and a negative 3, so that would be minus 7. Then to write this fully in simplest form, how you doing, Mr. Stubb? Do you want to write some algebra too? I'd love to. It's pretty good stuff. Geometry is my favorite. Geometry is really good. I can just finish for a second if you need something. No, just 5 seconds. Yeah. Now to simplify the bottom. We don't like to leave it in simplest form with those two binomials, so we have to FOIL the bottom out. So first, x times x would give us, come on, you gotta show off for Mr. Stowe.
X squared.
X squared, sweet. Now let's see, FOIL is f, so outsides, x times
3x.
3x, okay, FOI. Insides, Mr. Stowe.
Negative 1x or minus x.
Minus x, 1x, and then last,
Negative 3.
yeah, negative 3. So all the way in simplest form. Whoops. Perfect. Last step, x could not equal, what two numbers could x not equal? Look at our denominators.
0.
That actually could equal 0.
1 and negative 3.
1 and negative 3. Very good. Go ahead and do number 5. Buffalo is the same thing, except they can do screens and so on, but they prefer to go. Westie.
Yeah, Wesley. Good old.
And then it's that, and then 1311, and they're there.
What?
How do you structure?
Two big foes. Actually, no. These are. You replace Buffalo with Boston. Or you replace Boston with Buffalo.
It's like the loaded side.
I'm not gonna lie, I have no idea.
But I can go
Those are Seattle.
But Seattle was
How we doing? Number 5?
1 second.
1 second. Yeah, thanks. You have a question?
Yeah, are you gonna do like in the numerator my x
Let me see. Where is it?
So we multiply by each, okay.
Yep, good. Great.
Good grade from test.
Great, fantastic. I can double check just lay the time of the, yeah. Nice shot. Yes, I saw Ryan and Maddie. So,
Alright, that's as far as I'm getting.
you should not have your denominator correct in
Easiest part, give me
numerator.
the.
Something happened.
Well,
She distributed.
that is right. That is the thing.
Make sure you distribute the negative here.
Is there-
Yes, well, you just have
Your
to distribute
numerator.
this to
Your numerator should
five.
not have any extra.
Oh, so there's a minus right there.
Negative x minus nine.
So, this negative here, needs to be distributed to the x and to the 5.
Oh, okay.
So this should have parentheses, I mean technically this has parentheses around it, so then when you combine it, you distribute to negative 10 on top. Yep, x's would cancel, you negative 10 on top.
And have you
You
won
okay?
24 yet?
Eh? Make sure, I think you lost your negative sign. So
I
this should
did.
be a negative here.
I did.
Well, if we change that to a positive, then we should have negative x and negative 5. Right? Follow with me? We're negative, and if you want to change it to plus a negative, then we would need to distribute them to both things. Oh, we only have 4 more minutes.
Oh, shoot.
Alright, last example. Addition with denominators that can be factored. So, when we add these, I'll go through this fairly quickly and then we'll move to test review. When we add these, we have to have what?
Common denominator.
Common denominators. Good. Is that what you said? Yeah, okay. Perfect. So, we're not exactly sure what this is. Like, if this could factor out where one of the factors was x plus 2, that would be super helpful, right? So let's see if that would work. Before we even try to get common denominator.
Yeah, one is x plus two.
Is it? What's the other one?
2x minus
One more time?
2x
2x minus 1. So, again, this kind of shows too that when we're trying to factor these more complicated trinomials, we should look at other places in our problem to kind of get a hint for what one of our factors might be, one of our binomials might be. In this case, it works out nice. So, since they both have the x plus 2 in common, what do we need to multiply this first fraction by to get common denominator?
2x minus 1.
Yep. So if we multiply the top and the bottom by 2x minus 1, and this, I think this is the last example, the very last one at the bottom. Squeeze the inside. Now that we have common denominators, we can simplify. So let's FOIL this. We would have 10x minus 5 plus 7. So this would simplify to now, are we in simplest form? No. Well, that is one thing, but before we FOIL, is there something else that we could maybe look at?
Simplify.
Simplify where?
X plus 2 and 10x.
X plus 2 and 10x. Not quite.
Oh.
Come on, back row. What do we think?
Back row.
Right up here. Back row. Lauren.
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 Oh.
What can we factor out of the 10x and the 2?
2.
Are you in the back row or is your name Lauren?
Well, I was gonna say two.
Okay. We'll pretend like you did.
What?
We'll pretend like you did. Help us.
Ooh. Oh no, that's
Where did I hear it? Oh.
I got it.
No, I got it.
Okay.
Hey, we gotta finish this exam. This should be a positive right here. Did you say plus, Faith? I probably misheard you. This should be 2x plus 1. This should be a positive. That should be a positive. So that means this is a positive. So that means that's a positive.
Mm-hmm.
So that means this is not what we have.
Apparently 2 times 2 is 6.
That's okay. I missed the 2. So really here we should have 10x plus 12. Those are our denominators. Now we can factor 2 out of the top. Oh, no we can't. Well, we can. But it won't. It's okay. We'll do that later. I thought that was a problem. It's a later problem. Whoever said it at first was right. You just need to oil the bottom.
Thank you. Yeah, Andy.
Andy, you're really smart.
X cannot equal -2. My fault. There's one later, and then there's one later where you need to factor a number out of the top. And it will cancel. Well, you could write it as 2 times 5x plus 6, but that wouldn't like let you
Can we
translate.
What?
What?
Can we FOIL? It's not fun.
Oops.
Shouldn't it be like 2x? The same as the first one.
Let's see. This here would be 2x squared. This would be 1, 4,
Same thing as the first one.
plus 2. Right. There we go. Do we have time for you to do your one example problem? Probably not. So that we do not fall behind, I mean, we are, like, this is the point where then you spend the last 20 minutes of class or whatever working on the rest of this page. Since we're doing test review instead, we are not going to spend any, like, direct class time with this page. So it is up to you to do this at some point.
Got it.
That's
Okay.
reasonable.
I will collect the packet after